Okay, this is example 4 and 5 of the Algebra 1, Chapter 9, Section 3 notes, where we are solving by square roots. So this is the word problems. So it says a touch tank is in the shape of a rectangular prism. So if we do just kind of a rough sketch, so a rectangular prism is like a box. So my sketch is like obviously not to scale. I don't know exactly how big it is. All right. So roughly that. So it's a rectangular prism. It has a height of 3 feet. Okay, that's this distance. How tall it is 3 feet. Its length is 3 times its width. So if its width is W, its length is 3W because it's 3 times the width. The volume of the tank is 270 cubic feet. So think about how you find the volume of a rectangular prism. That's you do length times width times height. So the volume is 270 cubic feet. The length is 3W. The width is W, and the height is 3. So if we multiply that together, 3W times W times 3, that's 9W squared. So it says find the length and the width of the tank. Well, if we go ahead and solve, remember we have to get that W squared by itself before we can square root. So the first thing that we're going to do is we're going to divide by 9 on both sides. I'm going to come up here just for the sake of space because I was writing kind of large. So I get 30 because 270 divided by 9 equals W squared. Okay, and then to get W by itself, to get rid of the squared, you square root it. Remember that that is the inverse or the opposite of squared is square rooted. So you square root 30. And so if we just do this to the nearest tenth, we're going to type it in a calculator and we're going to get roughly 5.5. And I guess I'm actually going to say approximately 5.5 and negative 5.5. But we're not going to use the negative because you can't have a negative width. So then to find our length is 3 times W, so 3 times 5.5. All right, or if you want to go farther out, it was 5.477. So the more decimals out you go, the more exact it is. So if I do 3 times 5.5, I'm going to end up with 16.5. Or if you went out farther, more decimals, it might be like 16.4, but you'd still be close. The questions in the book should tell you what to round to. So the width is about 5.5, and this is feet. And the length is about 6.5, or I'm sorry, 16.5 or 16.4, depending on how you did it. And then feet. Okay, let's try another word problem real quick. So it says the area of an equilateral triangle with side length S is given by this formula. So A is area, S is the side length. This only works on equilateral triangles. Okay, it says solve the formula for S. So it wants us to rewrite this formula so that S is by itself. So we rewrote formulas, we called them literal equations back in chapter 1, but we didn't do one that had a squared on it. So the first thing we want to do is we want to move that square root of 3 over 4. So what I'm going to do that is I'm going to multiply by the reciprocal 4 over the square root of 3. And I have to do it on both sides. And the reason I do that is because then there's a 4 on top and on bottom and it cancels. Square root of 3 on top and a square root of 3 on bottom cancels. So what I have is on this left side I have 4 times the area, that's uppercase A, over square root of 3. And then on the right side, I have S squared. Okay, so to get that S by itself, I would square root both sides. So I end up with the square root of, it's a large square root, 4A over square root 3. Now I know technically we can't have a radical or a square root on the bottom of a fraction, but honestly, we're just rewriting to get S by itself because it asked us to. Then you could use this formula if they give you any area of a triangle to just quickly plug it in and type it in your calculator. And so we're not really trying to rationalize the denominator. We probably could, but I don't feel like it's the purpose here. So we're just going to kind of let it slide this time and move on to part B. So part B says approximate the side length when the area is 390 square inches. So it tells you that area is 390. You don't use squared. Square inches is just part of the label. So to do this, all you do is you plug in 390 for A. And that's the nice thing about already having this equation rewritten. I'm going to use this rewrote equation right here because it's already solved for S. And so I'm going to use this one, and I'm going to plug in 390, and I'm literally just going to put that in my calculator. So I type all of this in, nice big square root. I use my fraction key and everything to keep it just all separated out. And I end up with about 30 inches. So I rounded that off, but it was right at 30 inches. So that means the side of this traffic sign, the yield sign, is 30 inches long.